Ugh. You know, they don't make like, I can't even think of any opera stars. Catherine Battle, they don't make her sit here and like wait for they're ready when the star is ready. All right, everybody, I'm going to give a little talk. I'm going to actually talk about how to use spatial data. Can I move? Okay. All right, everybody, I'm going to give a little talk on using spatial data with Java, especially Java EE. You may think that all that spatial stuff is only good with Google Maps, and you have to be some sort of JavaScript ninja to do it, but I'm here to tell you no. I'm here to even tell you that you don't even have to use Google Maps. We're going to be using OpenStreetMap. Yes, it's true. Thanks for standing there. That makes me feel like I at least have an audience of one. So, thanks, Steve. So this is the URL for the talk. This is actually all hosted on Openshift. These are my talks. And this is me. And this is where you can find me everywhere. You can actually find me there as my email at Red Hat as well. So let's go ahead and get started. The agenda is a little bit about spatial data stores. So data that you can actually store spatial data in. Some JEE, but I'm assuming everybody here knows it. So I'm going to go through that really quick. And then I'm going to compare and contrast, because it's one thing to talk about all the spatial data stores, but I'm going to try to give some recommendations about when you might want to use some. So the assumptions are you write Java code. Is that a good assumption here at JavaOne? I feel like that might be. And then you will ask questions. So if you have questions, you can ask them. So the types of spatial data stores, I need to fix my CSS. There are several types of spatial data stores that are out there. So across the top, you'll see the different types. There's an example on the next one, and the bottom is the use cases for where they're typically used, even without spatial. So for example, we have relational data stores. We're at Oracle Open World also. Anyone heard of relational databases? Anybody? No? Okay. So before your time, exactly, the hipster hacker says, before his time. So we have PostGIS, MySQL has spatial, SQL Server does, Oracle does, it's their spatial blade, and Spacial, which is SQLite, only it handles spatial data. By far, the gold standard in spatial data, in relational databases, is PostGIS. It's the OGC, which is the Open Geospatial Consortium's reference standard for it. MySQL, with more recent releases, has gotten better spatial capabilities. SQL Server and Oracle have very good spatial capabilities as well. Spacial, even despite the fact that it's a file-based data store, has really good spatial capabilities. And you'd use that anywhere you basically use normal relational databases. Document data stores, examples of this are MongoDB and Couchbase. Both of these have spatial capabilities. Today I'm only going to be showing Mongo. When I'm talking about has everybody here used Mongo? Do I have to, no? Good, then I'll keep explaining it. So Mongo as a spatial data, as a document store, when I say document storage and search here, I don't actually mean like Word doc or OpenOffice doc. I'm actually talking about a JSON document. Right, and we'll talk about this in a little bit. Full text indexing, that's Lucene, Solr, and Elasticsearch. And if you were here earlier today, there was a talk about using Lucene, but I'm going to talk about the spatial parts about it today. And this is usually when you really are keying in on full text indexing. So when you have a bunch of documents or something that you want to search on the text. And then graph databases, there's the main one here is Neo4j, and that also has spatial capabilities. So if you're interested in directed graph databases, you can actually use Neo4j with spatial capabilities to do your queries against it. And it's usually used for relationships between things. So that could actually be between things. It's often used in a social interaction, right? Like so a social network graph. But this can also be, the census data uses graphs a lot, because if you think about it, things are nested in hierarchies. So it makes it very quick to walk down one whole node of the tree to decide who's in what census tract, who's in what the tract is within the block, which is in I'm getting the order wrong. But basically to walk down the county, the zip code, all that quickly. So let's start with PostGIS. This is the relational one. The basic notes on PostGIS, it's an extension to PostgreSQL. And it tracks it pretty closely. It's been around for at least 10 years. So this is actually very mature technology used in lots of different places. It does the full OGC spec for MMSQL. So OGC is the Open Geospatial Consortium, kind of like our JCP process. This is it for people who do spatial stuff, and they implement the entire spec for MMSQL. And it's got a metric ton, I wanted to make sure that was scientific, a metric ton of integration with other spatial software. So if you use QGIS or any other desktop software, GeoServer or map server, which are two spatial data servers. They automatic plug-in, it works with it great. There's a whole sorts of scripting languages, Python libraries to work with it, all sorts of stuff. Java libraries to work with it. And it is the standard within the free and open source GIS community. So the pros of it, it's extremely powerful and flexible. It has almost anything you want to do in Spatial, you can do it inside of PostGIS. So not only can you do things like intersection and near and stuff like that, but you can do things like buffer, and then clip, and then union, and then disunion, and all sorts of spatial operations and spatial modeling you can do, and aggregate based on spatial stuff. It has Hibernate integration, so a lot of Java developers tend to like to use Hibernate. And there is a Hibernate library to work directly with PostGIS. So you just store your objects as a spatial type, and it stores it right into PostGIS natively. You can do queries natively in Spatial and pull it back out as well. And it's a well-known technology. Relational databases have been around for a very long time. There's not a lot of surprises there. SQL's well known by everyone. So it's probably a tool you already have in your tool belt. You're just going to need to learn some of the spatial pieces of it. And there's lots of documentation. There's Manning books on it. There's a whole bunch on PostGIS. The cons is, because of the power, when you pick up the end of the stick of power, the other end comes steep learning curve, right? So there's actually a steep, you have to understand more about the spatial realm to work with PostGIS. Things like projections and datums and some other things that become important. Does everybody know what a projection is when we're talking about the globe? Right? When you all took, most of us, I'm looking at the age of most of us when we took our geography classes, when we looked at the map, Greenland was bigger than Africa, right? And all the lines of latitude and longitude met at right angles on the map. Does everyone know what that projection is called? It's called a Mercator projection. And the part why it's really good for navigation. It was a projection, because when you take a globe and you flatten it, you've got to sacrifice something. You can't keep it exactly accurate. So the Mercator projection was used because lines of latitude and longitude meet at right angles. So it makes it very easy to navigate. Most of us don't navigate anymore. And so there's a lot of other projections you need. And so you need to understand some of that stuff to understand some of PostGIS. It has all the same baggage as PostgreSQL. So any reason you wouldn't choose a relational database, you're not going to choose PostGIS. Right? So whatever baggage Postgres brings, this brings the same thing. And there's starting to be actually, this talk's a couple years old, there's starting to be a better scaling story now with PostGIS, but it's not really doing like, it's mostly master-slave replication. Right? So let's go on to Mongo. So a bit about MongoDB. In MongoDB, a document is just a bunch of attributes and values. So it's very similar to a Java hash map. Right? That is what a document means. And just like a Java hash map, you can put hash maps inside of hash maps and lists inside of hash maps. Inside of Mongo, when you're storing a document, it can be that complex and that deep. Right? It's just going to be JSON. Actually, it's going to be BSON, which is binary script object notation, because they want to be able to store dates. It allows you, dates aren't strings, dates are dates in there. It's got very simple spatial functionality. And so when I mean so when I mean very simple, basically it's for querying. Remember with PostGIS I said we could do things like buffer and then clip and do all sorts of really interesting spatial operations. With Mongo, the spatial is all about querying. So you can do near, within, and like you can use it on their find operator, right? So when you find something, you can say find something within this distance, find something that intersects, find something that's within this other thing. So you can say give me all the Burger Kings within this postcode, right? That's an operation you can do in here. So it's mostly just for trying to find ways to query by spatial things. Okay, that's the functionality it has. It defaults to data units from GPS devices. So by default, it's assuming everything's coming in from a GPS device in terms of projection and datum. And so that's actually really convenient for most of us because that's this. Right? So coordinates you get off your cell phone work perfectly fine. You can use other coordinate systems, but you're going to have to do some of the math yourself. It's schemaless. So this is by Mongo by default. This has nothing to do with the spatial pieces. Have any of you, now we've got a bigger crowd, how many of you have used Mongo? A few of you? Okay, so you maybe can help me answer these questions when I ask. When I say schemaless, there is a schema, but it's flexible. It can change at any moment in time, right? So if he's working on his code and he calls his collection, which is like the table players with an S on the end, and starts inserting data, And in my code, I query against player, not players, just player. No data will come back. If I start inserting, I forget the S, I insert into player rather than players, it won't complain. It'll just go ahead, start inserting data, and you have data in 2 different collections, right? So it does no error checking whatsoever in terms of any schema stuff. So typos are very bad because it won't ever complain to you that you've got the wrong field or I don't have that field, right? And it's really good at fast writes, but you give up immediate consistency, right? They have very primitive locking, like you're not going to get 2-phase commits out of Mongo. If you need 2-phase commits, you're actually writing it in your code. So basically, you're getting the simplicity and the speed because you're giving up some of the stuff that you come to rely on a relational database. So Mongo is definitely a tool in your tool belt. Just make sure you're using it for the right situation. And it's easy to horizontally scale. In general, both this and Couchbase scale horizontally quite well because they were built like that from the beginning, right? They're both relatively new when we came up with the idea of commodity servers that you just throw another server at it. Relational databases were built when machines were really expensive and it was easier to just throw some more RAM into it or replace the processor, so they have a harder time doing the horizontal scaling. So some pros, it's very simple to learn. There's no SQL statements to learn. You don't have to learn anything about projections and datums. You can just start using it. It's easy to set up, and you got all the benefits you normally get out of quote-unquote NoSQL, right? The cons are it's limited spatial, so if you actually need to do spatial modeling, it's not a good, you can't use it. And there's no stored procedures or DB error protection, none of that. It's all on you and your application code. And it's a newer technology. Now it's not so much, it's a couple of years older and there's a lot of people using it. It's just been shown, there's that whole hype curve for NoSQL. I think we've kind of gone through that in the trial of disillusionment, and people are realizing it's another tool in your tool belt that you use in some situations, probably with a relational database, and you just use it when it's right. Okay, so Lucene, how many people here have used Lucene? How about Elasticsearch? Or what's the other one? Elasticsearch and Solar, right? So both of those are actually Lucene, Solar and Elasticsearch are both based off Lucene. So anything you see today is actually available also in Elasticsearch and Solar, just exposed slightly differently. Okay, but all that capability is there. So a bit about Lucene. There's 2 steps to it, right? So you first take your documents and you create an index off of them, and then you search that index. So you basically build a static index, and then you have other code which actually opens it and searches it. Most spatial functionality comes from Spatial 4J. It's very simple yet again. It's basically querying again, right? You're not using Mongo and you're not using Lucene to do complex spatial operations. Lucene's use case is full text search, right? So you're not going to be doing some sort of complicated spatial modeling in Lucene. So if you need that again, don't use Lucene. It's also schemaless, right? But it's schemaless in a different way, in that once you define your index, you can define your index however you want, but once you build the index, it's stuck, right? Like you can't change the schema on the fly for the index unless you rebuild the entire index. Does that make sense? But it's almost like a key value store in certain ways, except you can have you can search against different keys and different values. And index is just a file on disk. Like I said, files usually on disk. It's also, like I said, it's also part of Solar and Elasticsearch. So any of those that you want to use, you can use those here as well.
I have a question.
Yeah?
When you add more content, do you have to re-index everything, or you incremental?
They have incremental indexing. But I'll come to it in a second. I think you can. I'll come to it in a second, though. So it's very simple to learn. I've learned it, so that makes it actually quite simple, because it's hard for me to learn hard things. It's just files on disk. So this is actually a huge pro, right? So if you need to scale your Lucene, you're just rsyncing files around. It's very quick. It's very easy. You can back up your index very easily. So your backup procedure is take those files, put them somewhere else. If they get corrupted, just copy them back. There's no, because you're not constantly writing to it and stuff. And it's got amazing textual and spatial search combined, right? So where Lucene really shines is when you're doing search against text, because it's got built in all sorts of really complicated text search functions. Snowballing, stemming, it's all built in different languages, how to do all that really interesting stuff, and then you can combine that with spatial things. So if you work for, let's say, an oil drilling company or an insurance company, and you're getting a lot of claims in, If you know the general location of the claim, you can actually put spatial data on the claim, and then you can say, find me all the accidents which would happen within this box, right? And you can say, how are they related? You can do really interesting queries that would be hard to do against full text otherwise. The cons is it's limited spatial again. It's only a few query types. It's not really geared towards frequently updated data. So yes, you can do incremental searches, but it's not like a high transaction writing thing. So like if you have, well, we'll get to it at the end when we go to where the use cases are. There's no on the fly field querying. So you define what fields are going to be queried when you build the index. You can't suddenly say, no, I want to add this other field once the index has been built. Once the index is built, you can only query on the fields that you said were queryable when you built the index. So it's not like relational, and it's not like Mongo, where you can query on any field you want to. So does everybody here know JaxRS and CDI, basically? Does anybody not? I'm going to skip this, and we'll show it in the demo. Okay? If you don't know JaxRS, JaxRS makes Java feel like we fit in with like all the Node cool kids. It makes it very, very easy to write REST services. You do a few annotations. You don't even have to do any serializing or deserializing of JSON, and you've got everything you. And actually, like I used that, and I was like, oh, I like Java EE now. This actually makes me really happy. And then like the new CDI is so easy to use. Oh yeah, I really like that I can inject like this. This is so easy to set up and use. So it's the cool stuff that makes me actually like it. CDI is context dependency injection, right? So it allows you to inject things where you want. I'm going to use this in the Mongo one, and I'm going to use it in the Lucene one because opening the connections is expensive. So I'm going to open it once in a bean that's application scoped, and then I'm going to inject it wherever I want to inject it. And then JaxRS is the anti-SOAP. Makes it super easy to write REST-like architectures. Right? That's kind of when SOAP came out, that was kind of when I walked away from all that. And this makes me happy to go back and easily do REST. So I'm actually building it. This is the application we're going to build. It's a map of the world, but we only have parks in the United States and Canada. Each of these dots is a piece of property owned by a national park service in the United States and Canada. Right? Let me see if I can make this bigger. It doesn't change the font size, does it? No. So these are, but we can basically zoom in and zoom out and look at these dots. These are dots that I downloaded off of one of the National Park Service sites. And as I zoom out, it's actually going ahead and re-querying and finding new sites again. Right? And as I pan and zoom, it does it again as well. Right? And this is actually, if you look down here, or you come up later, it's powered by Leaflet, which is an OpenScript Java library, a JavaScript open source library to work with OpenStreetMap. It can work with Google Maps and it can work with MapQuest, but it also works with OpenStreetMap. Does everybody here know what OpenStreetMap is? No? It's the Wikipedia of map data. So it's crowdsourced data for the entire world. And so like we just had that Hurricane Patricia that just swept through Mexico, or when we had the typhoons or the tsunamis. One of the great things about this crowdsourced data is they have interfaces where it's very easy for people to digitize data off. So like the earthquake in Nepal, I spent about 6 to 8 hours just digitizing in where houses were, and it was automatically in the database and available for everybody to share. So it really helped with responders. If you have your own company, you can put your own data in. Like there was a news site that actually went in and started putting in sites for everywhere they had a story so that they can then use the data and link the story off the map. Right? They couldn't, there's no way they could do that with Google. Right? They couldn't say, oh, I need to add this new location into the map. But you can do that with OpenStreetMap, and it's free for everybody to use. So that's what I'm using here. Right? And so there's a link here to how you get to it. I'll show my link to the whole talk again at the beginning. And here's Leaflet, and then OpenStreetMap. So links to those things I just talked about. If you want, at the end, I can show you the Leaflet code, but I want to show the different data stores first. All right, so I'm running this all on Openshift, One of the things is, though, that it makes it very easy for you to, does everybody know what Openshift is? You have a sticker on your backpack. Do you know what it is? Okay, good. You're going to tell everybody? Openshift? What's Openshift? It's Red Hat's platform as a service. It's the best Java platform in the as a service in the universe. So basically, what it allows you to do is just say, I want EAP or Tomcat. It spins it up, gives you a Git repo. You say you want Postgres, it spins it up, wires it all together, and you just write code. You're not administering servers, you're writing code, which is what I always wanted to do. One of the things you can do with this, I can do this. Let me find my Mongo one. That's my Hibernate one. Here's my where'd my Mongo one go? I closed both of them. Hold on one sec. 1 second, please. Okay, so I can just take this Git repo. Actually, I think the whole command line's right now. It's not here. Okay, hold on. I can just do rhc app create my map, and I can say EAP JBoss EAP. I think it's -6.4 that we're on now. MongoDB -2.4 -- from -code. And I give the URL, and I'm going to make it a large gear size, and it's going to say, what's your password, because I haven't used this account in a while. Which one did I get wrong? JBoss EAP. Anyone see it? JBoss EAP -6. This is the end of the showing the Openshift stuff. I'll show it at the end. But basically, this is going to spin up that entire application with that one command line. Right? So it's going to make an EAP server. Fine, medium. It's going to actually make the EAP server, and it's going to make the Mongo server. It's got hooks in it to actually load the database into the database server, and it'll all be running with a Git repo on my local machine. So I can just start modifying the code right away. I already have that app running. My map. We think, great developers think alike. Our creativity knows no bounds. So let's actually look at some of the source code. I'm going to show, actually this application, when I'm using the map, this is all done with JavaScript, and it's just making a call into a REST endpoint. Okay? So actually what was nice about this is I could swap the REST endpoints out, but because the signature stayed the same, I didn't have to change the front end. So there's nothing new I can show you here when I show the different services, so I'm just going to show code. Okay? So for the Mongo service, right? Here's the web service. And I give you a whole bunch of different ones, and this is the one I'm using. I need to make this bigger in the back, right? Yeah? In the back? Is that better? Is that better? That's good? Okay. So basically, this is normal JaxRS. I'm saying I produce JSON. My path is /ws/ I forget what the park /within. Right? So this is the URL. And then I'm going to say, here's the method. And then I'm taking query parameters for the bounding box. And so all that happens to make my Mongo connection is I've inserted this up above. There, I'm injecting the DB connection. And I'll show the DB connection in a second, but I've started up the DB, made a connector, and then I'm injecting it here because I don't want to keep starting it up every time I get a request. Okay? So then what I'm doing is I'm basically saying, if any of you have used Mongo, this looks very similar to Mongo's syntax. I'm basically saying DB, get the collection park points. So there's a table, which is called a collection in Mongo, called park points. Now I've got a handle to that collection. I make a DB object, which is this is how I make the JSON, that's the query string. So in Mongo, your queries are all JSON objects. So I'm basically making a JSON object where I'm making a pair of lat longs, right, the two corners of the box. Then I add that to this list of positions, so I'm making a list with two positions in it, which are just the two corners of the box. I say, that's going to be my box query, and I say box query put box with the two positions in it. So now I've got JSON, which is the two lat longs with box. So I'm querying on this box, and this is the actual query, position within the box query. Okay, so find any park where the position is within the box. And in leaflet, I can just say, give me back the view box. So that's what I pass in for my lat long, right? And so then I say park list collection, find, using that query. And then I get back a cursor, I iterate them. I have a method called process, which just goes through the JSON and makes it into a new form of JSON that I want to use to make the pins. and I say cursor close. So that's what a spatial query looks like in Mongo. Okay? In Hibernate, well, actually, let me show you how I make the connection. Let me go back to the DB connection. So this is the DB connection. It's super easy. I'm just basically getting, after I create the object, so after create, this is if I'm not on Openshift, it's a local host. If I am on Openshift, use the environment variables to get the port, the host. This was all stuff that was auto-configured by Openshift. The port, the password, the app name. Go ahead, make a new Mongo connection, and then I say get the DB, which is the same as the app name. And then that MongoDB lives up here, right? So then I can inject that whenever I want. I've got to get the DB, and that just gets that DB, right? So that's all I needed to do for that. It was actually really nice writing this little singleton like this to hold the connection and make it injectable. It was so much nicer doing this than back in the old days. It made me appreciate annotations. All right, so let's look at Hibernate. So this is with PostGIS. So let's look at what that query is. The exact same type of query. I'll just show you how it works. So here's again, application JSON, get the bounding box again, right? And now I make a geometry factory because I'm going to need to make that box. So in Spatial in PostGIS, you need to make a geometry factory to make a geometry. So I'm going to make a geometry factory. I'm making a string buffer, which is this is now the OGC syntax for a box. It's basically I'm concatenating a bunch of stuff together to make the OGC string for a box. So it's a polygon and it's got the four corners of the box. Okay? I read, this is what I was saying, it's much more complicated than using Mongo. So now here I need to take that geometry factory and make a well-known text. That's what WKT stands for. We were making well-known text back there. I make a geometry box filter. I tell it to read that and make the box. Then I make a query. This is actually a Hibernate query, right? It's not a straight SQL query. So create query, select P, select points from park point entity P, because this is Hibernate again, there's an entity, where intersects, the points geometry intersects the filter, which is the box filter from up here. So I set the parameter, filter is equal to box filter. So basically what I'm saying is get all the points where its geometry intersects the bounding box I made up there. And then this is another thing to process the query results and make the JSON again. Okay? And that's it for that one. And this, in Lucene, we actually need two different classes, or two different projects. So this is the indexer. This is just a straight up Java SE project. Oh, I never showed you what the data looks like. Do you guys want to actually see the data? This is the data that we were actually using in all of these. This is actually, so it's basically JSON documents with name equal to name, position equal to an array with a Latin long in it. This is incredibly easy to import into Mongo. You can just basically say Mongo bulk load, define a spatial index on pause, and you're done. In PostGIS, this is a lot of work. You actually have to process this and turn this into SQL statements or use your code to directly put it in. And when you have to make your schema beforehand, right? Again, with Mongo, because it's schemaless, I can just plow it all in and then make the index on that field and I'm done, right? And then for Lucene, I'm just going to read this using JaxRS and then put it into the index where I want to put it into the index. Okay? No, that's not what I wanted. That's me, in case you couldn't tell. So the index directory this is a built index. This Luke jar. Luke is actually a utility for Lucene that lets you load up a little swing application that lets you inspect your index files. So I put it in there so I could always have it around when I wanted to look at what was in the index. But the rest of these files, these are all the index. So those are really small and easy to move around. So let's go back here again, and here's the source code. So to index, we open the JSON file, We open the index directory. We do a whole bunch of object mapping, right? And then the object mapper reads the value, makes a park, and then the Lucene writer adds that park. So we're basically just going through, and I think it's this, no, that's actually just the park itself, the park object that we're serializing into the index. Yeah, it's the Lucene writer that does all the work. So notice this has a bunch of the spatial stuff in it. So you have to define an index strategy, you make the index strategy. All the work's actually happening here though. There's opening the index. So here's adding the park. So we open the index, now we're adding a park. So to a Lucene document, right, so a row across the Lucene document, we're adding a new text field with a name, and then we just get the park's name, and we store this field also. So you can index and store it because you want to display it when you get it back. You can index and not store it because all you want to do is search, but you don't want to take up space in the index. You just want to use it for your queries. So now we need to make a point. Remember, with all this stuff, what you're going to be doing is working with geometries in one way or another. So we're making a point shape. So from the spatial context, which we created way up at the top from Lucene, we make a point, and we get the corners of the park, right? And then we say, create an indexable field on point shape. So we're making different layers of spatial accuracy. So with Mongo, it's actually got a built-in spatial index, right? It uses, I think, B trees at this point. PostGIS uses GIST indexing, GIST, which is actually really flexible. What this one does is it actually uses boxes. It grids up the entire world at different levels of scale. And so what it does is it says, okay, I got the actual lat long. Which box does it belong to at this scale? Okay, which box does it belong to at this scale? Which boxes? And so it goes all the way down. We define that up here. It should be up here in the spatial. So here, we made the spatial context. We said geo, which means it's on a globe. We didn't actually have to project it. Then we said spatial context. We're making the geo hash, which is that blocks. And 11 says we want 11 levels of boxes, which gets us to sub-meter accuracy. Okay? So the trade-off you work with this is the more accuracy you have, the bigger your Lucene index is. So if all you're doing is mapping to like a postcode, you could probably get away with like 9 or 10, right? If you actually needed to say like this is where this pipeline is buried or this is exactly where this unexploded mine is, you're probably going to go out to like 13, right? All right, so what we're doing here is we're basically building fields in the document. We do a text field, we're adding all the spatial fields, then we add another stored field, which is the coordinates, but notice it's not queryable. So I want to store the coordinates because I need that in the JSON to put the points on the map, but I'm not going to query against it. So this is just stored, and then I add the document to the index, and when I'm all done, I just say finish, and it commits the writer, and we're all done. So that's the work that you go to make all the documents in, but then you need the application that actually pulls it back out. So that's actually going to be, I went in the wrong directory. In the web service again. Here. Query handler. Oh, so I made a query handler. I like when I get back. You can notice this is actually one of my later samples. So let me just show you. I'm talking to myself. This is the same thing we've seen before, but I've gotten better at making my JaxRS code more cleaner and cleaner as you see my samples progress. I'm actually calling out to a whole other object rather than mucking up my routing table, my routing class with all the business logic in it. So let's go find our query handler. And that should be in Lucene file handler, query handler. Okay, Openshift, Lucene. File handler just opens the file handles to the Lucene index. The query handler is here. So here it is. So I make a searcher. I have a match all docs query. Get an index reader, num docs is the total of hits. And I say for everything in, that's actually the search right there. So basically what I'm doing is oh no, wait, this is get all parks. Never mind, that's just the find everything in the index. Sorry. Here's the get parks near, get number near, get name near, get a box of points. So that's the one we're actually using, right? So I make a new map. I say set up spatial. So this opens up all the spatial pieces, sets up the index to the spatial context to be the same as the spatial context I made the index with. Is everybody's head over full already? Okay. Basically, you have to, in the Lucene index, you have to make the spatial things match up. It has to be the same in the query part as it is in the indexing part. If you don't make them the same, bad things happen. And so then I make a rectangle, I make a spatial args, and I would say I want it to intersect the rectangle, I make a filter, get index searcher, and then I go and I search using that filter. Okay? And then I loop through and do the stuff I normally do. So now you've seen all three sets of source codes. They all basically follow the same general idea, but the specifics, for me, PostGIS is the hardest to set up, and it was the hardest to get going. Lucene was second hardest just because the documentation wasn't as good at the time, and I was messing around. I don't know what it's like now. It should be better. They have a full-time person on it. But I'm going to get, and you can get to all these projects here if you want to look at the source code later. And here's how you can try them all, right? And then some recommendations, and my style sheet's messed up. So PostGIS, I say you use that when you need or foresee needing full spatial power, right? You want the full power of a relational database. Like if you think you're going to be doing transactions with your spatial data, you're not going to get that from anything other than PostGIS, because you need that Postgres underneath. You want to do the clipping and buffering and spatial operations on that data, you're going to need PostGIS. Like if you look at the functions that are available in PostGIS, you go look at the doc, there's a ton of things you can do with spatial that if you haven't done spatial before, you'll be shocked, right? It's like GIS. Any of you heard of GIS? And people who use like ArcGIS desktop, and they look down their nose at you and say, well, you just don't understand GIS. You could use PostGIS and say, yes, I do, and I actually run it faster and better. And you want more mature technology. Mongo, if your app just uses simple spatial queries, you need frequent updates, right? So you're doing a lot of pushing into the data, and you want horizontal scalability, right? You're not going to get that very well from here. Lucene, again, an app that just uses simple spatial queries, infrequent updates. So you can update, but you're not like on the fly updating all the time, people like doing a whole bunch of transactions in it. It has less moving parts, right? So it's a simpler stack. You don't have to worry about things failing. Once you write your Java code, there's no daemon to go down, right? Lucene has no daemon. It only has your web app that's opening the index and using it. So there's no, this part died, my app is still up, but this part died. It's just your app is up or down. And it's got a really good, if you really need advanced full text search. So let's wrap it up. More Than Google Maps is available for you in Java land. It's easy to build really interesting apps using spatial. I think building any app for any company, if you do something spatial with it, automatically they think you're a genius. Like as soon as you put a map up with points on it, people are like, whoa, how'd you do that? That's so great. You're really powerful. We should give you a raise. Do you want this boat? How about this boat? Openshift makes it easy. I showed you, and then come hang out with us for Openshift. I think, let's see if this is actually finished. Oh, I forgot to, yeah. Let's see if it worked though. So there it is. So I did that one URL, and there's my map up and running. Right, so you can actually there's a Git repo in there too. It didn't work because I didn't do the accept the key fast enough, so it couldn't actually do the Git checkout. It's doing it right now. Okay, so openshift.com, sign up online for it free, and I think my time is up. We can stop the recording, but if people want to stay around and I can show the leaflet code to see how I actually do the map, we can do that as well.